All right, welcome to the deep dive. Today we're going to be taking a look at the philosophy of John Locke.
Yeah, Locke, really a fascinating figure. I mean, his impact, on how we think about knowledge today, especially when it comes to, science, it's uh, it's pretty massive. You can't really overstate it.
No, absolutely. And for you, our listener, the one who's always asking those big philosophical questions.
The deep thinkers out there.
Yeah, exactly. This deep dive, we're going to explore Locke's perspective on, well, what even counts as scientific knowledge? Scientia.
That's the good stuff, right?
Oh,
Scientia.
yeah. And whether we can really ever truly attain it, especially
Yeah.
when we're talking about natural philosophy.
The study of, well, nature itself, right? The universe, the physical world around us.
Exactly. And I think that, one of the most interesting things about Locke, at least for me, is this sort of tension in his thinking. He was obviously super into the new experimental science of his time. I mean, how could you not be? It was revolutionary. But at the same time, he had this skepticism, about whether we can ever really get to a true scientific knowledge of nature.
Almost like he saw the potential, but also the limitations.
Yeah, yeah. That's exactly it. It's like this real puzzle at the heart of his philosophy, and that's what we're going to try to unpack today.
And to really get into that puzzle, to understand where Locke is coming from, we have to go back a bit. We need to look at the traditional idea of scientia, the ideal that he was both kind of building on and pushing back against.
Okay, so back to basics. Scientia, where did this idea even come from?
Well, like a lot of Western philosophy, the roots go all the way back to Aristotle.
Of course, Aristotle, the OG.
Right. For Aristotle, scientia was the top tier of knowledge. It's like certain knowledge of truths that absolutely had to be true, kind of like in math, when you start with axioms and derive theorems. You can't really argue with them once you understand the logic.
Okay, I see. So scientia is about knowing things with absolute certainty, no room for doubt.
Right. And Aristotle believed that this kind of knowledge, the scientific way, was all about understanding causes. But specifically what he called formal causes.
Yeah.
It's like the essence of a thing, what makes it what it is, the core defining nature of something.
So it's not just about knowing how something works, but why it has to work that way because of what it fundamentally is.
Exactly. A good example is, think about a house, right? You can talk about the materials, the bricks and wood and all that, but the formal cause is the design, the blueprint. It's what makes it a house and not just a pile of building materials. And that design dictates how it'll function, the kind of rooms it'll have, everything.
I get it. So this idea of formal causes, it applies to like everything, right? Not just houses, but plants, animals, the whole natural world.
Exactly. So natural philosophers, the scientists of their day, they took this Aristotelian ideal of scientia and applied it to their study of nature. They thought, okay, if we can grasp the essence of a plant or an animal, then we can understand everything about it with absolute certainty. We'll know why it has the properties it does, how it grows, how it interacts with other things.
So they were aiming for that same level of certainty, that scientia that you have in math, but applied to the physical world.
Exactly. And this was the dominant idea for centuries.
Yeah.
But then comes Locke, and he's looking at all this, and he's saying, hold on a second, I'm not so sure we can really achieve this kind of knowledge about the natural world.
Okay, so Locke agrees that scientia is the ideal. But he's skeptical about whether it's actually attainable when it comes to like physics and biology and chemistry.
Yeah, he's saying, look, there are some areas where we can get to that level of certainty. He thinks geometry is a good example. You define a triangle, and then boom, all sorts of things about it. And he even thinks morality can be a domain of scientia, certain moral truths that are just, well, true.
Okay, but not natural philosophy. So what's the difference? Why does he think it's so much harder to get that level of certainty when we're studying nature?
Well, to get into that, we need to look at how Locke defines knowledge itself. Because for him, everything comes back to how our minds work, how we form ideas and connect them.
Right, because if scientia is about having certain knowledge, then we need to be clear about what it even means to know something.
Exactly. And for Locke, knowledge is all about basically seeing how our ideas connect or don't connect. Like, do they agree or disagree? He gives different types of knowledge. So first you have intuitive knowledge. This is like immediate, obvious stuff. You just see it and you know it. Like blue is not yellow.
Okay, that's pretty straightforward.
Right. Then you have demonstrative knowledge. This is where you need a bit more, step-by-step reasoning. It's like a mathematical proof. You build up an argument, and each step follows logically from the previous one. And at the end, you're like, aha, I've proven it.
And both of these, intuitive and demonstrative, those count as scientia for Locke.
Exactly. They both give you that certainty, that sense that you've grasped something that has to be true. But then there's this third type of knowledge. He calls it sensitive knowledge.
Sensitive knowledge. Now,
Now,
that sounds a bit different. I mean, if scientia is all about certain clear connections between ideas, how does our experience of the world through our senses fit into that? Our senses aren't always reliable,
you
right?
got it. That's the key point. Sensitive knowledge is the knowledge we get from our senses,
Yeah.
from experiencing the world around us. And it's how we come to know about, like, physical objects, what he calls substances. And here's the big thing. Locke says this sensitive knowledge, this stuff that we learn about the world through our senses, it's not certain. It's probabilistic.
Probabilistic. You mean like we can only be pretty sure, but not absolutely certain?
Yeah, exactly. And this all ties into his really important distinction between real essences and nominal essences.
Okay, real essences, nominal essences. This sounds like a philosophy exam question waiting to happen. Break it down for me.
So the real essence of something, for Locke, is its, like, hidden structure. It's
Yes.
the way its parts are put together, often at a super small scale, is what makes it behave the way it does. A good example is gold. It has a specific atomic structure that gives it all the properties we associate with gold.
Right, like it's shiny, it's malleable, it's a good conductor of electricity, all that stuff.
Exactly. But we don't actually see that atomic structure directly, we just see its effects. So the nominal essence is basically just the set of properties that we observe and use to categorize and name things. It's like our working definition of gold based on what we can see and touch and measure.
So the real essence is the underlying reality, the deep down structure, and the nominal essence is how we label and categorize things based on what we can observe.
Exactly. It's like what we call gold is based on how it appears to us. But the true essence of gold, what makes it gold, is something deeper, something we don't have direct access to. And this really makes you wonder, right? Do our scientific categories really line up with the way reality actually is?
It's a deep question. So if we wanted to have scientia, real scientific knowledge of nature, we'd need to know those real essences, right? We'd have to understand how the underlying structure of a thing leads to the properties we observe.
Exactly. Locke thought that if we truly knew the real essence of gold, then we could figure out all its properties just by thinking about it. Like, we wouldn't even need to see any gold to know it has to be yellow and conductive. It'd be like knowing the properties of a triangle just by understanding what a triangle is.
But that's where his skepticism comes in, right? He doesn't think we can actually get to that level of knowledge about the natural world.
Right. He lays out a few big reasons why he thinks scientia about physical stuff is out of our reach. First off, he says our senses are just limited. We can't perceive the, like, super tiny parts of things, the fundamental building blocks. He has this famous thought experiment where he talks about microscopical eyes. Like, imagine if our vision was insanely powerful. We could see atoms and molecules. Would we really understand them? Or would we just see a whole new layer of complexity?
It's like, you zoom in on a painting and you see more detail, but you're still just seeing the paint strokes. You're not seeing the individual molecules of pigment.
Exactly. It's a great analogy. And then another big obstacle, according to Locke, is that we can't really grasp necessary connections between a thing's real essence and its properties. We see that gold is yellow and it's malleable, but we don't see why it has to be that way. It's just a correlation we observe, not some logical necessity that our minds can grasp.
Yeah, it's not like a mathematical proof where you see how one thing leads to another with absolute certainty.
Right. And then Locke brings up this really interesting idea about, like, how everything in the universe might be connected. Yeah. He suggests that maybe to truly know even one thing completely, you need to understand all its relationships to everything else, like how it's affected by everything else and how it affects everything else. It's this mind-boggling web of cause and effect.
Whoa. It's like to understand a grain of sand, you'd have to understand the entire history and future of the universe.
Exactly. It just highlights how vast and complex reality probably is and how limited our minds are in comparison. And Locke also points out, to emphasize this point, that there are areas where we can get to scientia, where we can have that certain knowledge. He says math is a good example, and morality too. But the fact that we struggle so much with natural philosophy, with understanding the physical world, well, that suggests there's something fundamentally different going on there.
So are you saying Locke thought we were just, like, inherently incapable of understanding nature at that deep level?
Well, he does speculate that maybe there are beings out there, with much greater intellectual powers than us, who can see those real essences and those necessary connections, like maybe angels or something. But for us humans, he thinks it's just beyond our cognitive grasp.
Okay, so if true scientific knowledge of nature is off the table, then what kind of knowledge can we have? What's the best we can do?
Well, that brings us back to sensitive knowledge. This is the type of knowledge we get from observing the world, from seeing patterns and regularities. It's how we form our ideas about things like gold. We see that it's usually yellow and it's heavy and it's malleable. And from those observations, we build up our understanding of what gold is.
But it's always tentative, right? Like, just because we've observed those properties together in the past doesn't mean they're guaranteed to always go together in the future.
Right. It's probabilistic. We're relying on patterns and correlations, not on some deep understanding of why those patterns exist.
So even our best scientific knowledge is still ultimately based on, like, educated guesswork.
Not quite guesswork, but yeah, it's based on what we observe, and it's always open to revision.
Right.
We might find a new piece of gold that breaks the pattern, or we might discover a new way of looking at things that changes our whole understanding.
So it's not scientia, but it's still valuable knowledge.
Oh, absolutely. Locke is clear that sensitive knowledge is still real knowledge. It's based on our experiences of the world, on the way things appear to us. It's just not, the absolute rock-solid certainty of scientia.
Now, this all makes me think, with all the advances in science since Locke's time, like quantum mechanics, particle physics, have we gotten closer to those real essences? Have we
Right.
surpassed sensitive knowledge?
That's a great question. And it's something philosophers still debate. I mean, on the one hand, it feels like we've come a long way in understanding the fundamental building blocks of the universe. We know about atoms and quarks and all sorts of things Locke could have never imagined.
Right, we've got the Large Hadron Collider smashing particles together, trying to figure out the secrets of the universe. It seems like you're getting closer to that deep underlying reality.
Yeah, but Locke might still say, hold on a minute. I mean, think about the way science works. We create theories, we make predictions based on those theories, and then we test them through experiments. It's all about how things behave, how they interact.
So we're still stuck in the realm of sensitive knowledge. We're still just observing patterns and trying to come up with the best explanations.
Well, it depends on how you interpret Locke. Some philosophers think he'd be impressed with how far science has come. They think he'd see it as a sophisticated way of refining our sensitive knowledge, getting us closer and closer to the truth, even if we never quite reach absolute certainty.
But others would say we're still fundamentally limited.
Exactly. They'd point out that even our most advanced theories are still based on our observations of the world. We're still inferring the underlying reality from what we can see and measure. And for Locke, true scientia would mean knowing those necessary connections, knowing why things have to be the way they are, just from the very nature of what they are. And that, they'd argue, is something we might never achieve.
Okay, so this brings us to another really important part of Locke's philosophy, his engagement with the corpuscular hypothesis. This was the, dominant scientific theory of his time. It was all about explaining the world in terms of tiny particles.
Right, the corpuscular hypothesis. Basically, it said that everything is made up of these tiny, indivisible bits of matter called corpuscles. And all the properties we see in the world, like color and smell and texture, they all come down to the size, shape, motion, and arrangement of these corpuscles.
So it's kind of like a really early version of atomic theory.
Yeah, in a way. And it was a really powerful idea. It helped explain a lot about how the physical world worked. But the interesting thing is that Locke's relationship with this hypothesis is kind of complicated. There's this tension in his writing between accepting it and being skeptical of it.
Almost like he saw its potential, but also its limitations.
Exactly. And that's what makes him so fascinating to study. So, on the one hand, you have Locke talking about these corpuscles and their properties as if they're the fundamental reality. He even says that if we could see the texture and motion of these tiny parts of things, we'd understand why things have the properties they do.
So he's kind of on board with the idea that the properties of these corpuscles are the real deal, and everything else is just a result of how those corpuscles are arranged and moving around.
Right. He even compares it to a watchmaker. He says, imagine if you knew everything about the parts of a watch and how they fit together. You'd understand how the watch works, right?
Mm.
And Locke seems to be saying that if we knew enough about these corpuscles, we could understand the whole universe in the same way.
It's like the corpuscles are the gears and springs of the cosmic machine.
Yeah, exactly. But then on the other hand, you have Locke calling this whole thing a hypothesis. He's careful to point out that it's just a proposed explanation, not something we can be absolutely certain about.
So even when he's using it to explain things, he's not necessarily saying it's the absolute truth.
Right. He's cautious.
Right.
And this is where his skepticism about knowing real essences comes back in. Remember, he thinks we can't really grasp the true nature of things, those hidden structures that make them what they are. So if those real essences are just the properties of these corpuscles, then we're still in the dark. We can't really know for sure what those properties are or how they work.
It's like we're trying to build a model of the universe, but we're missing some of the fundamental pieces.
Yeah, and Locke was aware of that. He even pointed out specific things that the corpuscular hypothesis, at least as it existed in his time, couldn't really explain. Like sensation, for example. How do these little bits of matter just bouncing around give rise to our experiences of color and sound and taste?
Huh.
It's hard to see how those things could just emerge from, like, purely mechanical interactions.
It's like, how do you get from a bunch of billiard balls colliding to the feeling of, like, the redness of a rose? It's a big jump.
Exactly. And then there's gravity. This was a big one, especially after Newton published his work on universal gravitation. The corpuscular hypothesis was all about, contact forces, like one thing bumps into another thing, and that's how they interact. But gravity seemed to be acting at a distance, across empty space. That was hard to reconcile with the corpuscular view.
So the idea that the sun could pull on the earth, even though they're not touching, that was a problem for the corpuscular folks.
Yeah, big time. And Locke wrestled with this. He was initially inclined towards the contact force idea, but Newton's arguments were pretty convincing. In the end, he seemed to think that maybe God had just given matter this power to act at a distance, even if we couldn't really understand how it worked.
So a bit of a mystery, but Locke was willing to accept it.
It seems so.
Mm-hmm.
And then there's motion itself. The corpuscular hypothesis relied on the idea of impulse, one corpuscle hitting another and transferring its motion. But even that process was kind of mysterious. Like, how does the motion actually get transferred? It's not something we can directly observe.
It's like, yeah, we see things collide and move, but what's actually happening at that super tiny level?
Right. And then finally, there's the question of cohesion. How do these individual corpuscles stick together to form larger objects? If everything is just made up of these tiny bits of matter bouncing around, why isn't everything just like a cloud of dust?
Good question. It seems like there needs to be some kind of force holding things together.
Yeah, and that was a big problem for the corpuscular hypothesis. People proposed different ideas, like maybe the corpuscles had little hooks that interlocked, or maybe there was some kind of pressure from a surrounding medium pushing them together. But none of those explanations were entirely satisfactory. And Locke saw this. He even questioned whether we could even really understand how anything could be extended in space if it's ultimately made up of indivisible parts.
So a lot of unanswered questions about the very nature of matter itself.
Yeah, and all these issues with the corpuscular hypothesis, they point to Locke's underlying skepticism about our ability to really grasp the fundamental workings of the universe.
So where does that leave us with Locke's view on the corpuscular hypothesis? It seems like he was both drawn to it and hesitant about it.
Yeah, it's complex, and philosophers have different interpretations of his true position. Some think that he was ultimately a supporter of the hypothesis, but that he was just being cautious about overstating our knowledge. They see his skepticism as a kind of like intellectual humility, a recognition of the limits of human understanding.
So they think he basically accepted the corpuscular view, but he just didn't want to be dogmatic about it.
Yeah, something like that. But others think that his skepticism ran much deeper. They think he saw the problems with the corpuscular hypothesis, the things it couldn't explain, and they see those as evidence that he wasn't fully convinced by it.
Almost like he saw it as a useful model, but not necessarily the final word on how the universe works.
Yeah, that's a good way to put it. And it's interesting because this tension in Locke's thinking, this back and forth between accepting the corpuscular hypothesis and questioning it, it actually reflects a bigger debate that was happening in science at the time. There were those who were really gung-ho about the mechanical philosophy, who thought we could explain everything in terms of matter and motion. And then there were those who were more cautious, who thought that maybe there were other forces at work, things we couldn't fully comprehend.
So Locke was right in the thick of this intellectual upheaval.
Absolutely. And it's important to remember that he was writing all this before Newton's Principia Mathematica came out. That book really changed the game. It brought a whole new level of mathematical rigor to physics.
Yeah, Newton's work was groundbreaking. And I'm curious, how did Locke respond to it? Did he see it as supporting the corpuscular hypothesis or challenging it?
It's hard to say for sure because Locke didn't write extensively about Newton's work. But we do know that they were friends and that they influenced each other's thinking, and there were definitely some interesting parallels between their philosophies. Like, they both emphasized the importance of observation and experiment. and they were both wary of making grand pronouncements about things we couldn't directly observe.
So a kind of shared humility about the limits of human knowledge.
Yeah, I think that's a fair assessment. But there are also some differences. Like, Newton was much more comfortable with mathematical abstraction. He was happy to work with concepts like force and gravity, even if they didn't have any obvious physical explanation. Locke, on the other hand, was more grounded in, like, everyday experience. He wanted his explanations to be rooted in things we could see and touch.
It's almost like Newton was pushing the boundaries of what counted as knowledge, while Locke was more cautious, more concerned with staying within the bounds of what we could be certain about.
Yeah, that's a good way to see it. And it's interesting because even though they had different approaches, they both ended up grappling with some of the same fundamental questions about the nature of matter and the limits of human understanding.
So a lot of common ground, despite their differences.
Yeah, definitely. And I think that's what makes studying them so rewarding. You see how these brilliant minds, working in different ways, were both struggling with some of the deepest questions about the universe and our place in it.
And those questions are still relevant today, right? I mean, we're still trying to understand the fundamental nature of reality, and we're still debating about the best way to go about it.
Absolutely. And Locke's work gives us a lot to think about. He reminds us that knowledge is hard-won, that we have to be careful about our claims to certainty, and that there will always be mysteries that lie beyond our grasp.
So, as we wrap up this deep dive into Locke's philosophy of science, what's the big takeaway for our listeners? What should they be thinking about as they go about their day?
Well, I think the biggest takeaway is that Locke challenges us to think critically about the nature of knowledge. He asks us to question our assumptions, to be aware of the limitations of our senses and our reasoning abilities, and to be open to the possibility that there might be things we can never fully understand.
A healthy dose of skepticism mixed with a thirst for knowledge.
Yeah, that's Locke in a nutshell. And I think those are qualities that are just as important today as they were in his time. Maybe even more so, given the complexity of the world we live in.
So go out there, observe the world, ask questions, and don't be afraid to challenge the status quo. Who knows, you might just stumble upon a new insight that unlocks a deeper understanding of the universe. And remember, if you really want to dive deeper into Locke's thought, check out his essay concerning human understanding. It's a dense read, but it's full of brilliant insights that are still relevant today. Thanks for joining us on The Deep Dive.
Until next time.